When you walk into the C level,
Okay.
write your name and your thing is on your left.
Alrighty. So we're gonna go ahead and start it.
He said, I don't care. Something like that. Yeah, basically.
Can I put this here?
Sure.
Just trying to find like a native spot.
Hello?
If somebody could close the door just for brightness reasons. My eyes are all weird. And why the heck did that come on, Mick? No, don't worry about it. I think it's okay.
Try to stop this meeting.
Escape? Or? Okay. All right. So I had the privilege of presenting this work at a conference called OOPSLA towards the end of October. And what I wanted to do in this presentation was basically do exactly what I did back there. Because not only do I want to sort of share this with you guys, I also want to get some criticism on the way I present as well.
You suck!
After I'm done, man. So that's kind of the motivation behind this brown bag. And I also want to talk about my experience at the conference, being this naive guy who's never really presented at a big conference like this. I have lessons I've learned, and I want to share that with you guys. So if you guys get to talk at these places, you're better prepared than I am. So I'm going to be in character. I'm going to be in the, ooh, I'm at a conference and I'm presenting, I'm smarter than you kind of mode. And try my best to fool you into thinking that. So there's a little bit of weird technicality going on here. I have a mouse that clicks on these things. Hopefully it'll work out, so don't, that may be part of the criticism that you will share with me later. So without further ado, so the topic is a step towards large-scale reuse on the web. And I want to sort of take a moment with you guys right now and think back in time, back to about 1995. And if you're around my age, there's a good chance that you were in your university dorm room, maybe in your underwear, who knows, glued to this screen of something like a PowerMac 6100. And you're staring at this thing called a web browser.
No, I was in my dorm room doing something quite different.
So, in retrospect, it really wasn't much to look at. It was this gray thing with some black text and some occasional blue ones with underlines. But by and large, it was a beautiful piece of art or any sort of breakthrough in technology per se at that point in time. Yeah, it had some images, even some perhaps rather annoying ones that were proliferating on the web. But again, it wasn't a state-of-the-art technology. And I'm not trying to play the role of the web browser in any way, but even back in 1995, there were other applications that did far greater image, text, and all that stuff being displayed in much nicer ways. So to me, it was kind of amazing to see how such seemingly inferior technology became popular so quickly and at such a large scale. Now, these college students weren't just tinkering for 2 minutes and going away. They were literally spending a lot of time typing in less than signs, greater than signs, and into their text editors, posting up family photos, favorite quotes, guitar tabs, maybe even links to porn sites, I don't know. These web pages were being created left and right, and there was no sign of stopping. So just how did the web get such a huge number of college students adopt this technology so quickly and at such a large scale? So it certainly wasn't the technology, as far as I can tell. There are far superior technologies out there that can do far better. And I don't think the web took off because it was a breakthrough in technology. I think it took off because it was simple. Now, it was simple enough.
That's great.
It was simple enough to let people play, tinker around, design, and create. It was great. Now, let me emphasize it one more time. I think it was simple enough to let people play, tinker around, design, and create. So once the web did take off, industry took notice, and it was a matter of time before people like us, software developers, got a hand on it. And as software developers, we have this innate desire in us, embedded into our brains since birth, that constantly whispers in our ears, almost like a divine inspiration of sort, that says, add more features. And that's what we do. So more features could be great, but in certain situations, it's not necessarily the best thing to do. And in this case, many people had different ideas on what the web should do and how they should be done. So what they tried to do was set up a standards committee, and they were busy web, trying to perfect the future, if you will. And they were using a very innovative approach to this design called design by committee. And in the meanwhile, the industry got tired of waiting for these design committees to finish their job, so people just started inventing their own standards. And some standards that were kind of begot from the industry turned out to be rather interesting and enabled new things to happen, while other things weren't quite so great and maybe some quite questionable in why they came about. But in more than one ways, the web was feverishly evolving, but perhaps without a clear vision as to where it was headed. Now, fast forward 10 years and to present time, and more broadband users were becoming on board. And the Netscape 4.0 finally fell off the face of the earth, which was a godsend for a lot of developers who were doing web stuff. And Mozilla project gave to a great browser called Firefox. And thanks to Microsoft, it stopped shipping newer versions of Internet Explorer to homogenize the browser market base. At least that's what I try to tell myself. But although not necessarily compatible, all these technologies were reaching a somewhat of a union of a feature set that were enough, it was comparable enough to let people do similar things on different browsers. So you can kind of see the stars were somewhat aligning to cause something potentially dramatic to happen, although it was only dramatic to the casual observer because from the outset it looks as if these things were happening overnight, but it never really is. It was something that's been brewing for a long time, and it was waiting for a time when these things kind of all aligned together. And probably you know what I'm talking about. What happened was Ajax, and many people hate the name. If you want people to use something, just give some name and tell your friends about it. Just good common sense. Too bad you didn't get to choose it, but that's what we have. Now, if you don't know what Ajax is, then you might have interacted with something like Google Maps. And if you interact with Google Maps, you kind of get this sense of responsiveness and sort of an overall rich user experience that you're not used to in a sort of a traditional web application environment. Now, whether you're a fan of Ajax or not, the point here is that the web would seem to have been kind of stagnating when it got over a slump, if you will. And with Ajax, things behaved cooler, demos were really sexy, engineers and users somehow felt kind of empowered, and people were once again getting genuinely excited about the web. But I think we all forgot something, because all these things come at a cost. And this cost I'm talking about is complexity. Now, you might have thought network bandwidth, but that's a whole other topic. Now, remember what I emphasized back in the beginning of this talk. I said the web was simple. It was simple enough to let people play, tinker around, design, and create. And that's why it was great. But now things that used to be simple were no longer so. And I'm not talking about website usability issues. I'm talking about something more fundamental. It was harder for the developers to develop things that met these sort of requirements. And the line between the end users and developers that used to be blurred back in the original web days were much more wider now. It's really about how crucial it is for complex technologies to be composed of simpler technologies to let people adopt it and easily innovate. Now, as a matter of fact, I go as far as to argue that it's necessary, potentially, for these complex technologies to be made up of simpler ones so that our feeble minds can grasp it and actually keep our sanities intact. Now, when you hear a person who may be a little bit overexcited about Ajax, it's quite tempting for some of us to, another technical issue, to kind of get on our soapbox and start yelling about the virtues of no-frills static web pages, blah, blah, blah. But let's face it, the world is spoiled and with this new technology, and there's really no going back. So yes, there's certainly cases where people misuse Ajax, but that's not an argument against adopting new technology. That's merely a disagreement in taste in the use of technology, not a fundamental argument against adopting new technology. So there are definite benefits to change, and every time it occurs, we tend to resist. Now, for those of you who have been in the business long enough to have seen several major technologies come and go, it's very easy to see that Ajax may just be another technology that happens to be trendy, and it's trying at its dying breath to keep the attention of the people on the web until it's superseded by another technology. And you're probably absolutely right. But the point here is that it is here now, and as practitioners, it's probably unacceptable to plead ignorance to the reality. And unlike philosophers, we don't have the luxury of just ripping out whatever is already done and just starting from scratch all the time. So the answer probably isn't to hold your old school fist up in the air and lament about how kids these days have no idea what it was like to implement server-side image maps or whatever you want. But instead, what we have to do is look at how the market has responded to this new technology, and we have to respond with an answer that would foster the excitement, but at the same time guide them so as to not to like let them become a lemming that just falls off the end of a cliff. Now, you may be thinking to yourself, wow, this guy seems super excited about this not a great technology. You can make HTTP requests without refreshing the page. Is that such a big deal? No, and that's not what I'm talking about. And that's not what I'm excited about. It's certainly part of it. But what I'm really excited about is this. Now that, to me, is exciting. And for those of you who have no idea what I've just shown, because it's pretty crappy resolution and such, it's a website called Programmable Web. What it shows you is a matrix of how modern web applications are really a fusion of other web applications. So if you see on each row, you see a lot of dots. And what that represents is that particular application over here happens to be composed of a bunch of other applications that are out there. And the trendy term for this is mashups. Now, these things, because the things we want to do now are much, much more complicated. But the problem is the technology that lets us do these things are equally complicated. And that's a shame. And you may look at Slither, what are you talking about, Slither? Hundreds of them out there. Is that really any indication that things are not simple enough? But you got to think back in time to 1995 when we were creating millions of things, not just hundreds of these things. So this is in no ways comparable. So what are we to do? So with complexity comes power, and a great designer never tries to compromise power for the sake of simplicity. What we do is we find ways to ensure that simple things are simple, yet complex things are possible. So we strive to find a path that will allow that to happen. So there are really three issues that we're talking about here. First is to bring back the simplicity that made web so compelling in the beginning and let people innovate constantly. Second is we want to foster the current excitement that are veered around this new technology. And we got to tie it all back to the original idea of letting people play, tinker around, create, and design freely once again. So now the question is, well, how the hell do we do this? But before we talk about how, let's briefly talk about what have we done, right? So a lot of us have the same goal. We want to make things simpler. Excuse me. That's great, but perhaps some of us have different ways of achieving that simplicity. And the usual gut reaction exhibited by software engineers like myself is when we say, oh, let's make this simple, we say, oh, no problem. We'll create a framework, and we'll bury deep, deep down there so you would never have to know anything about it. And that works in certain cases, and domain-specific ones may have more luck than others. But it's not without its issues. Some certainly have size issues, especially on the web. When you're talking about download size actually matters, you can't just tell them, oh, this great overly general purpose library of stuff that you'll download is only a megabyte, but once you have it, you can do great things. That's not going to work very well on the web, for example. And some are quite frankly stuck in the old paradigm of doing things, and they just pretend that HTML never existed, and they say, oh, you want a window? No problem. Here's a window object. You construct it with these 3 required parameters, call 3 more methods, and you set the width and height, and and don't forget to call .draw on it. It's going to be like MFC all over again. It's going to be great. It's going to be awesome. But I don't know about that. So, and the last type of folks are somewhat in denial, if you will, because they say, oh, we don't have size problems. We incrementally load scripts as they're needed. But frameworks are still frameworks, because what happens is You have a lot of tight coupling that's usually introduced by things like frameworks, and there are vendor lock-in issues. All these things are well-known problems with frameworks. So it's a good start, you can say, but I think we can do a lot better. One more technical difficulty. All right. So a better approach to solving this problem is perhaps not to provide a kitchen sink framework, but to lay a foundation for an ecosystem built upon a core set of design principles which can empower people to solve their own problems, yet without shooting themselves in the foot. In other words, don't try to design an end-all to world hunger at one shot, but provide an ecosystem in which the solution can evolve. An ecosystem which fosters growth, but not dictate them to do things in one specific way. So once we have such an ecosystem, we can let the individual stakeholders go off, innovate on their own, and create their own visions. As long as this ecosystem is built on top of strong principles, it will allow these innovations to occur more freely and organically. But of course, the important thing here is that these ecosystems have to be based on a set of strong principles that does in fact make this fostering of growth happen. And before we dive into the details of what we propose as such an ecosystem, let's briefly touch upon who can build such an ecosystem. Many times we try to set up huge, large organizations that have a lot of different stakeholders, and we call these design by committee. And they might have a place in society in making things happen, but we don't believe that's the answer to creating such an ecosystem. What tends to happen is when these guys get together to create new technology or innovate, you end up with overly general purpose things. This is a serial port with 25 pins, where some argue that you need 9. Maybe some people even say you just need 3. But you try to compensate technology for the sake of making every stakeholder happy, and you end up with a lot of bloated stuff that may or not be necessary. And there are a bunch of examples like this out there right now that we can point to. The second option is to let a player in the industry come up with their own innovation and let the market choose. And that's what de facto standards are. There's certainly good examples of how some of the simple technologies that have come about, RSS for example, that have let people do things that they weren't able to do in the past. This is the RSS icon.
Oh, okay.
Yeah.
I've seen it so good.
But at the end of the day, neither of them are really the fundamental answer to how we can create such an ecosystem. The real way to build such an ecosystem and to actually make a difference is to have a group of practitioners who follow principles and proven patterns that they apply over and over again whenever they're appropriate. So if these practitioners are going to be the ones depending on the ecosystem for growth opportunities, it's important that the principles that we base our ecosystem upon is strong yet fundamental enough that they're non-controversial. So some of the core principles that we've come up with that lay a foundation for such an ecosystem are relatively simple. And let me just quickly enumerate them. We want this ecosystem to promote and allow for component reuse. This will promote interface standardizations, it promotes reuse, etc. And we also want to allow systems to be naturally composed of these components that we just talked about. And so these components will be a building block of this ecosystem at large, if you will. And we want these components to be able to talk to one another. If they're just going to be in their silos, they may or may not be very interesting. But once they start talking to one another, it again goes back to the idea of letting it grow, extend, etc., etc. And we want these components to be uniquely identifiable because we want to distinguish one component from another, resolve other issues that are related to that. And we also want to allow some way of introducing hierarchical encapsulation at some level of granularity so as to manage the complexity of the system that may result. And finally, we want to let the people who are designing these systems to draw their own level of granularity so as to handle problems such as performance or level of granularity related issues. So the core patterns for implementing such an ecosystem are as follows. The ones we've decided to use are as follows. So we've decided to use a pattern of black box encapsulation. We've also decided to use composition. And we've decided to use asynchronous message passing, hierarchical encapsulation, and the pattern of universal uniqueness. And you should note that none of these is new. Not a single one of the patterns listed here are new. What we're doing here is pulling together a set of patterns that have proven to work well and promising to use them appropriately and rigorously. So now, in terms of having a reference implementation of this particular idea, JDA is basically an implementation of these patterns specifically for the web. And in implementing for the web, we have a handful of technologies that we're sort of bound by and we have to use. And they're things you're probably familiar with. So whether we like it or not, these are the ones that we're stuck with because they tend to be the ones that are most widely used. So at this point, I've blabbered on for long enough, and it's about time I show you a demo. But before I do the demo, let me quickly go over some of the main abstractions that I'm going to be using to describe some of the demos. And this comes from a larger research agenda at our company, My Design, that is called IDA, which stands for Information Devices Architecture. Oh. And the first abstraction we have is what we call an infotron. Second one is what we call a message. And third is what we call channel. So let me show you a quick demo to reiterate my point. So okay. So this is basically a ripoff of a well-known web mashup that fuses Craigslist and Google Maps. Except in this case, I'm using Yahoo Maps for no particularly good reason. And excuse the ugly interface. This is what happens when you let inmates run the asylum. So if you see a map, you see a map on the left-hand side and an empty table on the right-hand side. And basically, on the map are cities that are provided by Craigslist, where they have housing information for. So you can pick a city and you click on one of them, and what happens is the list of housings available in that city for rent is going to appear on the table on the right-hand side, and you also see those shown on the Yahoo map on the left-hand side. And when you click on one of the listings, you get further details on the map with a zoomed-in image, along with some contact info and such on the map there. No surprises here. Again, this is simply a rip-off of the Craigslist mashup. Except this is implemented atop of an ecosystem. And what the hell do I mean by that? What I mean is the following. So this is a blueprint that shows what the individual building blocks are that make up the particular mashup I showed you. The rectangular black boxes are what we called infotrons, and the red lines are basically channels that let these different infotrons talk to one another. You can get a sense of the modularity and the loosely coupled nature of the system by looking at how these things are sort of laid out and composed together. And I mentioned that I used Yahoo Map in this particular example, but I could easily swap out that particular component with another one, such as the one used by the original Craigslist mashup. They use Google Maps, for example. So what I can do is I can find myself a Google Map equivalent and drag it out onto the blueprint. And then basically what I can then do is route all the red wires going into Yahoo Map over here, and then rewire them so that it goes to Google Maps now instead. So of course, this is obviously assuming that these two components have matching interfaces. And as long as that's true, no other part of the system has to actually change. Of course, this assumption may seem like a naive one, but until you have this sort of ecosystem, you don't even think about producing matching interfaces, because in API-based tight coupled systems, matching interfaces mean several things. Same function names, same parameters, etc. But in this case, it's doing message passing, so a lot of that is mostly about conforming messages. So now, if you see this one, it's the exact same interface, except the Yahoo map is swapped down with the Yahoo map is swapped out with Google Maps. So if you pick a city, again, the same city, you click on one of it, the data gets routed, and then the housing list coming from Craigslist gets populated on the table on the right-hand side. And then basically the same thing happened with the map, where all these listings get shown on the map. If you click on one of them, now the information that you used to see on Yahoo Map gets displayed in a Google Mappy way, so to speak. But you'll notice that the zoomed-in image is still from Yahoo, because we did not swap that component out. Yahoo Map got swapped out, but the map image still comes from Yahoo. So you can see how it kind of shows you how the rest of the system stayed exactly the same. Now, in a model-driven architecture that still use strict OO practices, when you build things like this, you end up with a lot of glue code. About a third of the code may be glue. But in our sort of message passing infrastructure, you don't have that particular problem. So now, if you're curious about what this looks sort of down in the raw, I can show you the HTML that configures all these things instead of showing it in a visual sense. And I'll try that. And this is a movie, which I have no control over. Hopefully it'll go to the view source pretty soon. There you go. All right. So basically what I'm trying to show here is that all this is plain HTML. There's no trickery happening in terms of complicated server-side automatic code generation or something. It's just a bunch of divs that basically say, here's an infotron, here's its UUID, here's how it's connected, here are some properties, and see what you can do. Tell me what the system looks like once these things are in place. So assembling systems in this world basically means editing HTML to introduce new components and filling out some additional attributes that lets you assemble them together. So, yeah. So, all right. So that's the first demo. Go back to the slide. All right. So just to kind of go over some of the implementation details of this particular implementation. If you're familiar with JavaScript, although it's the year 2006, we're basically stuck with the feature equivalent of a pound include. What happens is every time you load a script, it's going to clobber up your global namespace, and what you can do is hope and just pray to God that the script you just loaded does not have any name collision issues with your code. So that's the first thing we had to fix. So how do we prevent namespace collision in JavaScript? And so the pattern that we've come up with is basically to create a function called blueprint, which lets you pass things in. And one of the parameters is actually a class factory, which you can implement your class in there and return it, so as to not clobber up the global namespace. It's a simple pattern. And when you want to introduce that particular thing in the HTML world, basically create a div with the pointer to that UUID and some properties and its connection. If it's connected to something else, you might specify that. I'll go into more detail later on that. And it turns out that writing something like that function to allow encapsulation kills two birds in one stone. What happens is, one of the other hurdles of JavaScript is you never know when your script is fully loaded if you're dynamically loading them. So if you want to do lazy loading of script, what a lot of people do is they have a timer that periodically checks to see if a certain function is finished loading. And other browsers have handlers for that, but it's not consistent across all platforms, so it's hard to do that. But now that we're actually using a function to introduce a new implementation, by the time the function is called, it's obvious that the script has been interpreted, and so there's no question involved in kind of doing guessing work to find out whether those things have been finished. And Another thing we've done is we've implemented an asynchronous message passing kernel in JavaScript that weighs in at about 6 kilobyte in gzipped format, relatively lightweight, and doesn't try to do more than that. It's very simple. And here is a sample code of an infotron that you might conceivably write. What it does is basically just sets a timer for 1 second, that's 1,000 milliseconds, and then at the end of that timeout, it basically posts a message saying, time's up, and whoever gets that message might do something about it. So in this case, you see those two highlighted portions of this code base, which shows that you're declaring the fact that you have a certain terminal, and then you create a method for it, the actual handler for that message, down in the body of that. And then in order to talk to other people or other components, you also declare an output terminal for yourself, and you post a message out through that same output terminal, and then hope that somebody gets that. And again, the component assembly is done via HTML. And this is an example of a simple blueprint that shows you how you may have two components that are connected to one another. Here we see the timer that I just introduced, and here's basically another infotron that happens to be an alert box. So whenever something comes out and arrives at the alert box infotron, it'll pop open an alert box saying hello world, for example. So in this case, you see certain ways to customize these particular instances of infotrons by using an attribute called properties, and to define the configuration of the connections, you use another attribute called connections. And another thing that happens to be, it's more of a side effect of this particular implementation, but one of the nice things about this is that you can separate logic and UI more cleanly. So in the previous paradigm of using sort of a more of an OO type of approach to creating user interface objects, you would end up with the code like this, where you instantiate some kind of a window object or a GUI object with some initial properties that you may call some methods on it to populate it with certain data. And then you might want to register a event handler in case that you want to know about when somebody clicks on my table, for example. In our way, what you can do is write your infotron and basically just write the actual GUI in plain HTML down in the div as part of the HTML itself. And as long as you have the UUIDs match up, it will basically take on the behavior imposed by the particular infotron. The nice thing about that is not just a separation of logic and UI, but also this is much faster. So the moment you load your web browser, you see the UI rendered. You don't wait for JavaScript engine to kick in and then start parsing those things and calling those methods to see the actual result of these programs. So my second demo, this city list provider infotron, which basically shoot out a list of cities that the Craigslist has housing info for, and goes to another infotron, which is a service on Yahoo, which happens to be able to convert city names into geocode. Then it gets passed into the Yahoo map for actual display. And then when you click on a certain city, that gets routed all the way to another component that goes to Craigslist and gets the housing information for that particular city. Then that gets routed into the table view for actual rendering. So, and when you click a certain row on a table, that gets routed to another Yahoo service, which gives you a map for that particular location, a more zoomed in version. And that again gets passed into Yahoo Maps to be displayed in that little the internal region. So that's the basic overall data flow of this particular thing. And you'll notice that not only components that do visualization, like tables and such, all the things that are web services are equally modeled in this way. So there's no real disconnect between the way you access remote services versus local services, visualizations or calculations, whatever. They're all basically black boxes that are connected to one another. The abstraction is maintained. So I want to kind of show you the extensibility aspect of having such an ecosystem. So once you have built something like this, you kind of notice the currency of the system. In this case, you say, oh, there seems to be a lot of geocode being passed around. What else can I do? I'm an engineer. I want to add more features. That's what I do. So in this case, you might conceivably say, I'm going to throw in another visualization component, which, although you can't see right now, is a grid that basically lets you lay things out in certain grids. And you might decide to say, I want to see all the photographs people have taken around the particular location I choose. Because before I decide to live there, I might want to see what the hell it looks like. So that's what I've gone ahead and done. So if you click on a city and want to get a listing of houses provided for that particular city, you can do the same interaction. You click on Georgia in this case, and then wait for the actual information to be populated in the table. And then you click on one of them, and now it not only goes and does the same thing that we used to see, which is the zoomed in Yahoo map, it also goes to Flickr. The same information goes to Flickr and gives you all the photographs taken at that particular geolocation and gets fed into another visualizer, which is a simple sort of grid layout guide. And you can kind of do this over and over again because, again, I just add features. So in the second example, what happens is, well, I want to see some grocery stores around this housing area because I grocery shop a lot. That's what I do. I don't know. So again, you do the same interaction. You click on Georgia. You wait for the list. You wait for the housing list to become populated into the table. You click on one of the guys you're mildly interested in, and now you get the image, the map show up, the Flickr photos for that particular location, and the list of grocery stores that are close by, right? And I don't want to bore you too much, but I'm going to do one more. And let's just say that, well, I pretend to be hip, and what I want to do is only live in locations that have hip events going on. So I'm going to add one more component to this particular system and say, I want to also see what cool events are happening in that particular location. And this one in particular goes to upcoming.org to get the particular events for that geolocation. So again, you click on a city, and then wait for the list of housing to populate. You click on a particular location of interest, and now you get the zoomed image, the location, the photos, the nearby grocery stores, and events in the neighborhood. So that's basically how one may conceivably, one approach to extending the system, knowing that the currency of the system is geocode. And I want to also briefly touch up on the notion of hierarchical encapsulation. So by the time you add gazillion features and such, you run into a case where, wow, boy, this whole thing becomes rather complicated. I've got 20-something infotrons in my system, and I'm starting to lose it, and maybe there's a logical way of grouping things so that it can be better reused for other purposes. So what you can do, at least the toy demo that I'm about to give you, what it does is, it says that the nearby grocery stores, the events happening in the neighborhood, as well as the photographs, are, let's just pretend that we're going to logically group them and have them be more easily reused. So in this case, you see a lot of infotrons. Then you say, well, I'm going to take the ones that, like the photo grid, the list view, and so the local search for grocery stores, and the events, and all those guys, and put them in one component that makes this entire system easier to grok and also makes that component as a whole more reusable. So if you did that, what would happen is you would end up with this system where all those other stuff were gone and became just a single component that I just happen to name auxiliary info view, which is an encapsulation of all those cruft at the bottom of the page. So now when you go back to the system built in this particular way, it looks more or less identical, except it's all messed up looking. So when you refresh the page, what happens is you see the basic same idea, and all the same components are down there shown in the same exact location. And the interaction is, again, the same. You go and click on a particular city, and you wait for the list of housings to populate in your table. And when you see one of them that you are interested in, you click on one of them, and you know the story, you get the photo, the grocery store events, etc., etc. But now, the fact that we've kind of refactored this guy out happens to be kind of an interesting motivator for also different interaction strategies. So in the next demo, what happens is I've intentionally set a property on that guy so that it behaves as if it's a top-level window. So you've basically said, I love pop-ups. What I'm going to do is pop something up and show those auxiliary stuff in there and not bother to show them in the main window. So, so what you do is, I'm just going to stash this aside a little bit because I don't have much real estate. But if you go back and do the same thing, if you choose a city to click on, again, back to Georgia, Atlanta, Georgia, click on it, and then you get a list of housings available for that particular location, and then you pick one of them, and then you get a phone call. And you pick one of them, and then you get the image displayed on the map as it used to, but now the other information is inside a pop-up. And this is literally just a single property. You didn't have to actually change anything in terms of code or etc. So now another thing you could potentially do is, no, I don't want to annoy people with a pop-up the moment they arrive at this web page. I'm going to do this lazily. So I'm going to go to this page, click on a city, and then I'm going to pick a room that I'm interested in, and then, and only then, will I pop open that extra stuff and show you all these priceless information about that particular location that'll end up convincing you to buy this particular real estate or renting it, etc. And again, all this is simply driven by property, and most people who are familiar with HTML would do these things, not necessarily having to wait for a programmer to implement a new feature or anything like that. So that's kind of a nice side effect of being able to refactor these things into parts. So, excuse me one second. But basically, so the last slide I had was recapping what I've said. This is basically talking about an architecture or an ecosystem, if you will, that basically says, let's not try to design an end-all solution using something like a framework, but instead have something that will let people sort of evolve their own solutions, but guide them so as to allow those things that they make be more reusable and more extensible. So in closing, I heard the speech that Christopher Alexander made at 1996's UPSLA on my first day here at the conference. And notice that he asked whether software practitioners like architectures in the real world are really trying to build things to better lives. And I believe we're absolutely doing, at least I believe we're intending to absolutely do that. And if that statement is true, I think we have some work to do, because we have not yet seen any real concerted effort put forth by practitioners to apply a lot of important lessons we've learned in patterns, architectures, computer science to better this particular technology piece. What I've seen most happening are people sort of resisting change and are treating this as simply a toy. I mean, while it's true that the web may not be the most interesting or challenging computer science problem, but the web is affecting users' lives on a daily basis. And given how closely people are interacting with these particular technologies, we as practitioners should try our best to apply our best knowledge to a popular platform. And the idea of having such an ecosystem that will foster that kind of growth and momentum, I believe, is a good thing to have. And I believe in the end, if we can all go back to letting people, promoting the spirit of letting people play, tinker around, design, and create, I think that would be a great achievement that we've made. So that's it. So I hope you enjoyed it. Thank you very much.